Morning, students. Let us next see about the good and the bad conductors of heat. Now, two aluminium tins of the same size you take, two small glasses, water, thermometer, black paint, etc. Now paint the outer surface of one of the tin with black paint and let it dry. Then in both the tins, place one glass, each filled with water at the same temperature. Cover the tins with the lids. Keep them in the sun for 2 hours. Now measure the temperature of the water in the glasses in the two tins. Now what is the reason for the difference in the temperature? We will see that the tin which is covered painted black, the water in that the glass of that black tin, it is more hotter than the water in the other tin. Now the reason for this is that the black paint absorbs more heat and so the water in it becomes more hot. Now let us next see about here certain substances, objects you take, and you have to classify them into good and the bad conductors of heat. Now place a steel spoon, a copper strip or rod, a divider from your compass box, a pencil and a plastic ruler in a glass beaker. Pour hot water heated up to 60 to 70 degrees Celsius into the beaker. Wait for a while, then touch the outer end of each of the objects. You will observe that steel spoon, copper strip or rod and the divider, it is hot, whereas the pencil and the plastic ruler remain cool as the atmosphere. Now reason for this is that the steel spoon, copper strip and a divider are the good conductors of heat, whereas plastic ruler and pencil are the bad conductors of heat. So this is the inference, what inference we do draw from the above experiment. The inference drawn is some substances are good conductors of heat while some are bad conductors of heat. Heat is easily conducted through a copper strip or pot but not through a plastic or wood. So they are the bad conductors of heat. Now we can hold a glass tumbler or a china cup full of hot tea in our hand, but not a steel or the copper cup if the same tea is poured into them. Now again the same reason is there that the glass tumbler or the china cup, they are bad conductors of heat. So even if they are containing a hot tea in it, the heat won't be conducted through them, and so we can hold the plastic tumbler or a china cup of hot tea in our hand easily. But the same tea, when it is put in a steel or a copper cup, as they are good conductors of heat, they will be heated easily and we won't be able to hold in our hands. Now the next question arises, why do we use white clothes in summer and dark or black clothes in winter? Now we know that white clothes do not absorb heat. So in summer, weather is very hot and white clothes protect us from heat. Whereas the dark or the black clothes absorbs more heat and so it protect us in winter. Now next we will see the expansion and contraction of the solid substance due to heat. Here a metal ring, a metal ball, a burner, etc. Now here take a metal ring and metal ball of such size that the ball just passes through the ring. Heat the ball and check whether it passes through the ring. You will see that it will not pass easily. Now let the ball cool down and check whether it is again passing through the ring. It easily passes. So you can see here in the figure, before heating, this metal ball can pass through the ring, whereas after heating, the metal ball is not able to pass through the ring. The above experiment tells us that metals expand on heating and contract on cooling. Solids expand due to heat and come back to the original state if the heat is removed. However, the extent to which the different solids expand, it is different. Then next we will see here a question, why there is a gap at the joints of rails and the cement concrete bridge. Now joints of rails and the cement concrete bridges are made up of iron. Now metal is a good conductor of heat. So in summer it expands due to heat and its length will be increased. So to allow for expansion, the gaps are kept. Now if the gaps are not kept after expansion, the rails would have the rails would have buckled up and the tracks would get crooked, or the cement concrete bridge would crack. So this is the reason that there is a gap at the joints of rails and the cement concrete bridge. Now, as in solids, there is expansion and contraction of liquids due to heat also. Now, here take one conical flask 500 whose capacity is 500 milliliters. To hold rubber stopper, glass tube, measuring ruler, thermometer, stand, wire gauge, burner, graph and paper. Now fill the conical flask completely with water. Insert the glass tube and the thermometer in the two holes of the stopper and fit it to the conical flask. Heat the water and with the help of the ruler, record the water level in the glass tube after every 2-degree rise in temperature. We observe that when the water is heated, the level of the water in the tube also increases, and when we stop heating, the level of the water in the tube comes down. So this shows that when a liquid is heated and the distances between its particles increase and its volume too increases, this is called the expansion of liquids. So when its temperature falls, the liquid contracts. Now, so like solids, liquids to expand on heating and contract on cooling. Now the next question is, why is mercury or alcohol used in a thermometer? Now the clinical thermometer, that is the thermometer used to find out the fever that you must be having at home, or you must have seen it in the with the doctor. Now why the mercury is used in a thermometer? Because it has the following properties. There is a big difference between the freezing point and the boiling point of mercury. Its freezing point is minus 39 degrees Celsius and its boiling point is 357 degrees Celsius. Now it is shiny and it can be easily seen. Then third reason is it does not stick to the glass. And fourth reason is it expands regularly and uniformly in all conditions. Now, why alcohol is used? The reason for this is that it can measure a very low temperature because its freezing point is very low. It is minus 115 degrees Celsius. But it cannot measure higher temperature as its boiling point is low. Then it can measure the temperature precisely because it has large expansion coefficient, then its expansion is regular as mercury and it is less hazardous. So thus alcohol is used in a thermometer to find out the temperature, lower temperatures less than 0 degrees Celsius, and mercury is used to find out the higher temperatures, that is up to higher temperatures, that is up to 357 degrees Celsius, as its boiling point is 357 degrees Celsius. Now next is here, after this we will see the expansion and contraction of gases due to heat. Now we know that here, now the gases to expand on heating and contract on cooling. Now this consists of glass bottle, balloon, hot water, etc. Now fix a balloon on the mouth of a glass bottle. Hold its bottle in hot water, and now we have to see what happens. Now the volume of the gas increases on heating. This is called expansion of the gas. On the other hand, on removing heat, the volume of the gas decreases. So this is called as the contraction of the gas. And so the balloon is blown up. This means the gas has expanded, air has expanded, and it moves into the balloon. So thus we have seen that the solids, liquids and gases, they expand on heating and contract on cooling. Now next we will see about the thermos flask. Now all of you know that this thermos flask, it is used to keep the milk, tea or the coffee hot, or even the water can be kept hot for a longer time. Now if you have seen a thermos flask used for keeping tea, coffee, milk hot, or a sharbat can also be cold, kept cold for a longer time. So what is the structure and how does it function, that we will see now. Now this thermos flask, this is a double walled flask and it consists of two glass tubes, one inside the other with a gap between them sealed. Now the surface of both the tubes are made shiny by a silver coating. Now air between the two tubes is removed to create a vacuum. Now there is a protective jar of metal or plastic outside the tubes. Now for the protection of the flask, the pieces of sponge or rubber are fixed between the outer jar and the flask, so that it does not break. Now here see, this is the structure of the flask. So here you can see these tubes are there, which is glass tubes which are kept one inside the other, and there is a vacuum between the two tubes. Now outer glass and then outer surface, it is made up of plastic. So that space between this glass tube and the outer plastic surface, it is filled with the sponge, and then inner surface, it is silvered surface of the glass is there, and then there is a vacuum here, and here the rubber support is there so that this glass tube does not break, and here the sponge is there in order that there is the insulation and it is a bad conductor of heat. So the loss of heat will not be there from the thermos flask. So hot or the cold liquid, it will be kept inside the glass tube. Now hence heat is not radiate. Now here, when a hot substance is placed in a thermos flask, the heat going out gets reflected due to the shining surface of the inner tube. Hence heat is not radiated. Neither conduction nor convection of heat occurs because of the vacuum. As a result, heat is not transferred to the outer cooler region and is retained inside for a long time. Still, a little heat is lost from around the lid and by a small amount of conduction through the glass. Therefore, the hot substance does not remain as hot after 2 or 3 hours. Okay, so now next we will see here what is meant by thermoware. Now this thermoware, this answer I'll give you when we are discussing the exercise. So I hope this chapter is clear to you.